Good morning, everyone. Today I'm gonna be talking about the lateral corticospinal tract, and I would like to start talking about the fibers because the fibers of this tract will originate in the precentral gyrus of the frontal lobe, which is part of the cerebral hemispheres, and especially related with the motor area. And this tract is located deep within the lateral funiculus of the spinal cord and will primarily consist of fibers originating from the contralateral, which is the opposite side, contralateral cerebral hemisphere. And with only a small number of fibers arising from the ipsilateral, which is this side here. Okay, and these fibers represent upper motor neurons and synapse on anterior horn cells in the spinal cord. Now, talking about clinical information that might be relevant for you. Before I move to the clinical information, I would like to first label these structures here. So we have this one here. Okay, and remember that is descending. Okay, so descending towards this way, all the way here to this point, and here to this one. Okay, now this one. Okay, this one is called corticospinal corticospinal okay, all the words together. Fibers crossing the median plane. Median plane. Okay, and here we have the uncrossed corticospinal fibers, here all the way down to this part. Uncrossed corticospinal tract. And this one consists mainly of crossed pyramidal fibers together with a few uncrossed fibers. And we have this one. It's important to add this arrow just to remind you that is descending. And then we have this one right here. Okay, we have this one here that's mainly the same of this one. Okay, I think that it's clear now. Here I want to label it this way, is the lateral corticospinal tract. Lateral corticospinal tract. Okay, consisting mainly of crossed pyramidal fibers together with few uncrossed fibers, as you can see here. And what I'm gonna do, I'm gonna make this midline just to represent that this fibers are crossing contralateral, okay? And here we have the spinal cord. We have a transverse image of the spinal cord. Okay, and this part here is the anterior horn. Okay, anterior horn. Now, the corticospinal fibers crossing the median plane in the medulla oblongata. Sorry. So the majority of corticospinal fibers cross over to the opposite side of the body at the level of the medulla oblongata, which is not represented here, in a structure known as the pyramidal decussation. And this crossing will be crucial for motor control because allows the left hemisphere to control the right side of the body and vice versa. Now, when damaged these fibers, it can result in contralateral hemiplegia or weakness, depending on the extent of the injury. For example, a stroke affecting the left hemisphere may lead to paralysis or weakness on the right side of the body. Uncrossed corticospinal fibers, this here. So this is a small percentage of corticospinal fibers. This small percentage do not cross over at the pyramidal decussation, and it will remain on the same side of the body. These uncrossed fibers are more common in the lower limbs, and it will play a role in fine control motor control. So when injured, these fibers can lead to subtle deficits in motor function, especially lower extremities, because it's found much more in the lower limbs. Now, lateral corticospinal tract. You probably are tired because you were listening me. You can hear me talking about this structure many times. And just a moment. Okay, back to the lateral corticospinal tract. The lateral corticospinal tract is composed mainly of crossed pyramidal fibers and a few uncrossed fibers. And it descends through the lateral funiculus of the spinal cord. And this tract is responsible for voluntary motor control of the limbs and trunk. And when injuries affect the lateral corticospinal tract, it will result in contralateral spasticity, which is characterized by increased muscle tone and hyperreflexia along with weakness. Now, anterior horn cells, you probably are tired as well, because I've been talking about the anterior horn and the lateral corticospine for a while. The anterior horn cells are lower motor neurons located in the ventral horn of the spinal cord, and they receive input from upper motor neurons and directly innervate skeletal muscles. When damaged, the anterior horn, the patient might present flaccid paralysis, where the affected muscles become weak and exhibit decreased muscle tone. And this type of paralysis is often seen in conditions such as poliomyelitis and amyotrophic lateral sclerosis. Yeah, this is pretty much what I wanted to share with you guys. I think that, yeah, this is the content of today. Just to wrap up, the corticospinal tract plays a crucial role in transmitting motor signals from the brain to the spinal cord and muscles. And when you understand its anatomical organization and clinical implications, you will notice that diagnosis and managing neurological disorders that affect motor function will be much easier to interpret. Okay, so yeah, this is the content for today. I hope you enjoyed, and I will see you on next time.